Hello and welcome to our webinar, Introduction to Amazon ECR, Amazon EC2 Container Registry. Our presenter today is Shai Perednik, who's a cloud infrastructure architect with AWS. We'll begin momentarily, but first we have a couple of housekeeping reminders. Today's webinar is being recorded and we'll send out a follow-up email containing the on-demand links to the presentation deck, as well as the webinar recording. Additionally, today's webinar has Q&A moderators on hand ready to answer any questions that you have. So use the Q&A pod that you see on your screen to submit those questions at any time, and our presenter and moderators will answer them live. Without further ado, I'll turn it over to Shai. Shai, thank you. Welcome. The floor is now yours.
Thank you for joining today's webinar. Today we'll be talking about an introduction to Amazon ECR, the Amazon EC2 Container Registry. This presentation was put together by my colleague Mitch Belmont, who is a solution architect, and I am Shai Perednik, a cloud infrastructure architect. On today's presentation, we're going to talk about a couple of things. The first thing we're going to start off is the AWS Container Ecosystem. We're going to talk about what Amazon ECR is, some of the features of ECR, and we're going to see a demo of ECR in action. So my name is Shai Perednik. I'm a senior cloud infrastructure architect with the AWS Professional Services team out of New York. I spent the last 20 years in IT, and I recently moved from California to PA. I started my career in California working with small organizations and startups. I moved to Pennsylvania because I got an opportunity to work with one of the big 4 audit firms, as well as an organization in oil and gas, and even some public sector organizations. And I quickly realized that there's really no barrier, no reason why an organization could not adopt cloud in some form or another. Really adopting cloud would make an organization be able to innovate and move quick. So that really brought me to AWS, where I really found things like ECR, ECS, EC2, S3, and many of the other services we have allow really anybody to be successful and innovate on a scale and pace that we've never seen before. So the next slide is, we'll talk about the container ecosystem. And so we have the EC2, the ECS EC2 container service. It's a highly scalable, high-performance container management service, allowing you to run managed containers across a cluster of EC2 instances. We integrate ECS with CloudWatch and CloudTrail for service monitoring and logging, and it also integrates with our CodeStar services for CI/CD pipeline delivery. Next one up is the ECS CLI, and the ECS CLI is a higher level, more developer-friendly CLI experience, allowing you to more easily manage your container cluster environment, as well as your container registry. The EC2 Container Registry is why we're here today, and we're going to dive deep into this. This is our Docker-compatible, fully managed image repository service. So what is Amazon EC2 Container Registry? ECR is a fully managed, secure, and highly available Docker-compatible registry service. ECR supports private Docker repositories with resource-based permissions to enable fine-grained access to images at the EC2 and instance level. You can use the Docker CLI to push, pull, and manage Docker images. All the tool set that you're familiar with will continue to work. The main thing is the simplified workflow that we've enabled, similar to the rest of our AWS services. So let's look at the anatomy of a Docker image. And so what are Docker images? Docker images are packaged code or binaries. Really give you a way to portably move things from on-premise, from your desktop to production and to various environments. In the past, we used to have problems getting reproducible results from development to the cloud. That's gone with Docker images. We used to have shared dependency issues, multiple languages that can exist on a single host. That no longer is an issue. Our Docker images are reproducible, they're immutable, and they're portable. And they're consistent across all our environments. So let's talk about how images are constructed. So our Docker images are constructed of layers. These layers are immutable and they're read-only. They hold file and configuration data for each part of the image. In this case, we're looking at a simple hello ECR with the latest tag. We see there's 3 layers here. And because Docker's union file system, each layer overrides the previous layer. So if you look at the bottom layer that ends in 7E5, that might be our base layer. We might have our base configuration data, the things that change the least, and then we'll layer on the changes as we go up the stack. If we have a file that's in that base image, or that base layer, and we continue to change that file as we go up the stack, that file will get changed in the latest layer. So let's look at a typical user workflow. So we have a user here, and he says to himself, I have a Docker image, and I want to run the image on a cluster. The user first pushes one or more images to their Amazon ECR repository. The user creates a task definition that specifies one or more containers required for the task, including the ECR repository and image, memory, and CPU requirements, any shared data volumes they might need, and how the containers are linked to each other. The user uses the task definition created earlier and runs the run task or create service command via the CLI to deploy the containers to their ECS cluster. So let's talk about ECR components. Your first one is the registry and repository, your registry policies, your images, and your authorization token. Your registry is provided to each AWS account. You can create image repositories in your registry and store images in them. Your repository is then an image repository that contains all your Docker images. You can apply repository policies to control access to your repositories and the images within them. You have your images, we talked about before. These are your Docker images that you store in your repositories. You can use these locally in your development systems or use them in Amazon ECS task definitions. Your authorization token is what your Docker client needs to authenticate to Amazon ECR registries as an AWS user before it can push and pull images. The AWS CLI get login command provides you with authentication credentials to pass to Docker. Let's look at pricing and availability. So as of today, ECR is available in 13 regions. You have a 12-month free tier for 500 megabytes of image storage. You have 10 cents per gigabyte per month in Docker images for storage pricing, and the standard AWS data transfer rates apply. Let's talk about some of the features and integrations into other AWS services. So the first one we have is the Amazon EC2 Container Service integration. The EC2 Container Registry is integrated with Amazon ECS, allowing you to easily store, run, and manage container images for applications running on Amazon ECS. All you need to do is specify the Amazon ECR repository in your task definition, and Amazon ECS will retrieve the appropriate images for your applications. The Amazon ECS container instance role that you use with your container instances must possess the following IAM policy permissions for Amazon ECR. And so these are some examples of IAM policies: the ECR batch check layer availability, ECR batch get image, or you have the option of using the Amazon EC2 Container Service for EC2 role managed policy. So I know it's a mouthful, but you can find it as you're going through your IAM policies, and we provide this as a managed policy. So that's the key: as the ECR and EC2 Container Service change, so will this policy. Now remember, as you're creating your images and you're creating your task definitions, remember to use the full registry/repository tag naming convention. So let's talk about the Docker Registry version 2 API. The Amazon EC2 Container Registry supports Docker's latest v2 API. Things like push, pull, like we talked about before, list, tag, or any of your preferred Docker tools in your tool set to connect with ECR. So you can maintain your existing development workflow. You don't really need to change anything. You can easily access Amazon ECR from your Docker environment, or from any Docker environment, whether it's in the cloud, on-premise, on your local machine, anywhere. So we're going to try to understand the underlying layers of what happens in the background of an ECR call. Once we do that, we can then look into ways of improving and optimizing our layers. So first thing we're going to do is we're going to pull down the image. We do a Docker pull with the URL, right? So Docker pull registry URI /image -name :tag. This URI is unique to the account. So what then happens in the background, we see the Docker daemon. The Docker daemon then goes and fetches the image manifest @tag. And then for each layer it doesn't have, it goes and fetches and it downloads that layer. So if we take this and we translate this to the HTTP calls that happen in the background, you'll see the commands, right? We issue that same command, and then we have the get/v2 image name. It's an HTTP format. If you can see the power, you can see how this gets to be pretty powerful. If the layer is there, like the base, you don't need to download anymore. And the great thing in Docker version 110 and above, Docker can pull these layers in parallel. So you can see how laying your images can have great benefits to speed and agility. And you really will start going down the path of optimizing your layers and optimizing your Docker images. So how does Amazon S3 high availability and durability play into all this? Well, Amazon EC2 Container Registry stores your container images in Amazon S3. Your data is fully redundant and stored across multiple facilities and multiple devices in each facility. And if you're not familiar with S3, it's a highly scalable object storage. You can store and retrieve files from anywhere on the web, and you store your files in high-level folders called buckets. So let's look at some examples of things like team collaboration and access control. And so we start off with team collaboration. With Amazon EC2 Container Registry supports the ability to define and organize your repositories in your registry using namespaces. This allows you to organize your repositories based on your team's existing workflows. So you're not changing anything, you're using those existing workflows. You can set which API actions another user may perform on your repository. Create, list, describe, and get, right? Those basic Docker commands that you know. You can control those through resource level policies, allowing you easily to share your repositories with different users in AWS accounts. So they don't just have to be somebody on your team, they can be somebody in a different account. You can share access with them. Repository names can support namespaces, which you can use to group similar repositories. For example, if there are several teams using the same registry, Team A on the left and Team B on the right, they each have their own namespace. Each team can have their own image called web app. But because they're each prefixed with a team namespaces, the two images can be used simultaneously without any interference. Team A's image could be called Team A/web app, while Team B's could be called Team B/web app. So let's look at access control as an example. Security is still day zero at AWS, and it's part of our shared security responsibility model. AWS is responsible for security of the cloud, while the user is responsible for security in the cloud. And so we can see how these access controls are similar to IAM policies. And so ECR uses identity and access management, or IAM, to control and monitor who and what EC2 instances or other users can access your container images. Like we said, an example before about team collaboration. Through IAM, you can define policies to allow users within the same AWS account or other accounts to access your container images. You can also further refine these policies by specifying different permissions for different users and roles. So for example, you want to have a user that's a developer. You want that user to be able to push and pull. You really don't want them to do anything else. You might have somebody else in a different type of developer role, and they can list, get, and describe images and do all of the other things in ECR, but they can't push or pull new images. So let's take a look at encryption. You can transfer your container images to and from EC2 Container Registry service via HTTPS. Your images are also encrypted at rest using the Amazon S3 server-side encryptions. So let's talk about some third-party integrations with ECR. So we have a couple good vendors like Twistlock, Tenable, and Aqua. But one of the examples I want to bring to light is Kubernetes. And so Kubernetes have native support for ECR. You simply use the full package name, and all the users in the cluster and the pods will run pods of these images within the ECR registry. Kubernetes will then fetch and periodically refresh ECR credentials, which needs a special set of credentials to do so. In this demo, we're going to be taking a look at creating your first EC2 registry. If you remember, the registry is your location, your repository for holding all your Docker container images. And so we're going to start off by going to the EC2 container service. We're going to click on Create Repository. And for this one, I'm going to call it ECR Demo. We'll make a note of your repository URI down here. You're going to click Next Step. And with that one click, you've gone ahead and created your first EC2 container registry. We see all the CLI commands, which we'll be going through in some of the next demos. And we hit Done. We're then taken back to the main repositories page, which sees it for our ECR demo. We have our permissions, our dry run of lifecycle policies, and lifecycle policies, all which we'll be taking a look at the next couple of demos. So in this demo, we're going to talk about pushing an image with the AWS CLI. In the previous example, we had used the console. So we're assuming already that you have an AWS account, you've configured your IAM user, and you've installed your CLI. If you haven't, the ECR documentation has a good getting started guide that starts with ECR. Once you go through this, you'll set up your ECR account, you'll have your AWS CLI installed locally. You can also run your CLI out of an EC2 instance. And then you continue with the Docker basics. This guides you on installing Docker, creating a Docker image, actually running that image, and then we'll talk about pushing that image into the registry. So let me bring up my console here. So now in our terminal, we're going to go ahead and create a registry again. Even though we did it in the previous example with the console, we're going to do it via the command line just to kind of illustrate how quick it is. So in the ECR create registry, create repository, and type in the -- repository name, and I'm going to call this one hello world so you can follow along with the documentation. And we'll make note of our repository URI here. We'll copy that one. And then we'll go ahead and we will tag the Docker image. So we'll run the Docker tag command. And my image is already built. And so we're going to tag that, and then we're going to tag that with that URI. And then we're going to go ahead and run the get login command, so that allows Docker to log in to our repository. And we're going to add the no include email flag because that's not necessary. And now all we want to do is we want to copy this entire command. We'll go ahead and paste that. Enter. Login succeeded. Let's go back and copy our URI for the next step. And next command we're going to run is the actual Docker push. So we're going to run Docker push, put in that URI, and it's going to go ahead and push out the image. And we'll see that latest digest message confirming that it's been uploaded. Back to our console, we hit refresh. We'll go ahead and see our hello world repository. And in that repository, we'll go ahead and see our latest image that we've just pushed. View all the tags, see the information there. Okay, so in this demo, we're going to be talking about task definitions and container images. We're going to start off on our ECS task definitions tab. We'll go ahead and hit the create new task definitions button here. Give it a task definition. I'm going to use the hello world. I'm going to select an IAM role that I've created before. You can choose your networking mode for your Docker container. And so you have bridge, host, or none. In this case, I'm going to leave it at the default bridge. And then we're going to choose our container that we're going to build from the image in our repository. So I'm going to flip back to my ECR repository here, copy the URI. I'm going to use the latest image tag here. Again, this could be a dev image. Just paste that there. And we'll do latest. Call this hello world container. We're going to find a memory limit as well. I'll use the default 128. I'll use the port mapping of 8080 since my Apache on the container image is running on 80. And that's really all you need. You have more advanced container configuration settings for your environment. You can define your CPU units, some of the commands you want to run when the container starts, your working directory, environment variables, more advanced network settings like your DNS servers and your search domains, storage and logging settings for adding volumes, and your security settings and resource limits. So we're not going to add any of those for this example. We'll just go ahead and hit add. And we can add some constraints. We don't need any in this case. I will go ahead and add a volume here. Just call it the log vol. In this case, maybe used for my Apache logs. I'm not going to define a source path. I'm just going to let Docker go ahead and define that path. So I'll hit add. We did this via what we call the builder. You can also do the same thing via JSON. So if you want to go ahead and just enter all these commands via JSON, you can do that here as well. It's pretty straightforward. And then you can also hit, and then we'll finally hit create down here. That'll go ahead and we'll create our hello world task definition. You can see it's tagged as revision 1. So let's say I want to go back and I wanted to change something, maybe my CPU limits. I will go ahead and create a new revision. And I'm going to go back here, and let's say I said, well, you know what, 128 is not enough. I actually need more. I need 256. So I'll just go ahead and update that one. Maybe I need to change some other environment variables. Hit update. And then I'll go ahead and create that revision. And you'll see now we're at revision number 2. And so we have the output, what we did via the builder. We also have our JSON configuration here. And that concludes this demo. Finally, for our final demo, we're going to cover the Amazon ECR Lifecycle Policies. And so we're on the dry run of Lifecycle Policies rules page, the tab. And we want to generally, as best practice, create our policies as dry runs first, so we can see how they affect and what happens. And so this is an exciting feature. It was really announced less than a month ago. And remember, Amazon ECR is a fully managed Docker container registry, so you have to worry about the challenges of scaling. What we've seen in the past is that this means that development teams use ECR actively and fill up their repositories with tons of images. So it really makes it difficult to kind of comb through, clean up, and do all those things without writing scripts or getting kind of clever. So this lifecycle rule policy is actually pretty cool. It really allows you to remove old container images automatically. So you can set these rules, you can preview them, and you can see what happens. So hopefully allowing you to be better organized. And so we'll walk through the demo here. And what we're going to do is we're going to add a dry run policy. So under the dry run lifecycle rules again, we'll hit add. Give it a weight. So again, this priority is an arbitrary number. It can be anywhere from 10 to 1,000, but we want to weight our rules. We're going to give our rule a description. So in this case, we might call it, say, delete dev or delete images, or let's say delete dev images. So in this case, we want to delete any development images that are tagged, and we're going to do it as dev. And we can also do untagged. So let's say we want to do delete all images, and I'll show that in the next example. So in this case, we're going to delete all dev images, and let's just do so we have 2 options here. We have image count more than or since image pushed. So image count more is, if there's more than 30 images or 60 images in the repository, we want to delete them. So we'll only keep a maximum of, let's say, 30. And since image pushed is going to be since the last day. So I'll show that in the next example. So image count, we're going to do more than 30. And the only rule we can apply today is expire. So we're going to save that. And you can see it doesn't execute it yet because you actually have to save and perform the dry one. We'll go ahead and also add a secondary rule here. And we'll call this one production images. Older than 90 days, right? I don't want any production images that have been around longer than 90 days. In this case, tagged, we'll call that prod. And we're going to do since image pushed, and we'll do 90 days. And we'll save that. And then we're going to add, so we'll run that one. So we'll go ahead and run those 2 policies. In the meantime, we can go ahead and click add. We can add a third one here, and we'll call this just general cleanup. And we're going to delete all untagged images, and if they've been around for longer than 180 days. Save that. And we're going to go ahead and save and perform the dry run. So we can go ahead and just check the ones that we want to do. It'll run through. And this could take longer, depending on how many images you have. In this case, it's coming up with no results because I don't have anything older than 90 days or 30 days, or anything tagged dev for that matter. So you can kind of see the power here of the lifecycle policies. And then what we can do is, once we like these policies, we can then go ahead and apply them as the lifecycle policies. Which now they will be enacted on. So before they were dry run, just showing us what the results of those dry run would be. In this case now, their actual lifecycle policies, and will be in effect. And that concludes our series of demos. So let's talk about optimizing performance for ECR. So as we've already known, we've talked about before, Docker images are composed of layers. Each line in the Docker file represents a creation of a new layer. As of Docker version 1.10, Docker pushes as many layers as possible as simultaneous uploads to ECR. So this leads to your faster upload times. Many default images contain dependencies that your application doesn't need. So consider using smaller images. Things like Scratch or Alpine Linux. You want to start with as much of a base as you can. Another cool thing is that Docker can cache layers, which can really speed up your build time. So if nothing on that layer has changed since the last build, Docker uses that cached version instead of rebuilding that entire layer. But remember, each layer is dependent on the layer which came before it. If a layer changes, Docker recompiles not only that layer, but any layers that come after that as well. So you want to place things with little dependencies that don't change earlier in the Docker file. That will really help you optimize that build and the upload process. So let's talk about some of the things that we've covered today. So ECR, like S3 and ECS, is a fully managed Docker image registry. It's compatible with Docker Registry version 2 API and integrates with Amazon EC2 Container Service, CloudWatch, CloudTrail, and many of the other AWS services. It really gives you fine-grained access control using identity access management policies. So one of the things I'd like to do is I'd like to encourage you to take ECR for a test spin. Use your existing Docker toolset and upload your existing Docker images. Then, if you still have time before going home for the day, take those ECR images, create ECS task definitions, and start deploying container images to a fleet of EC2 instances today. Thank you very much. Appreciate your time, and stick around for any questions.
Thanks, Shai. That was a great presentation and an awesome demo as well. As mentioned, we're going to transition over to the live Q&A format. Please answer the poll questions that you see when they appear on your screen, and additionally, hang out to make sure your question gets answered live.